Good morning to my lecturer and students. Today I want to present for my task 3 days presentations for the topic 2, linear programming. In my course, what is MTS 11074 Basic Algebra. My name is Benson Won Kishon and my index number is 202106231077. Okay. Before we start to learn the linear programming, we need to know the algebra, and let's get started to know the algebra. This is the introduction of algebra. Algebra can be viewed as a language of mathematics. It is commonly accepted that competence in a country's language is essential for your opportunities in that country. The same may be said about algebra. Competence in algebra is essential for people across all types of educations and professions where they use this language. To learn a country's language takes time and is measured over time by intensive training through listening and by training to use it yourself. And it is usually easier for young children to start learning it than for adults. To some extent, the same can be said about algebra, except that in mathematics, you learn arithmetic first, as arithmetic is the basis of algebra. So it seems reasonable to start with algebra after some fluency in arithmetic. This is the simple introduction of algebra. Okay, application of algebra in daily life. Most of us use algebra every day. Simple problem that we do in our head. For instance, say we have $20 and you go to the store. The store is having a buy one and get one at half price sale. How do you figure out what you can buy? Okay, there's an equation for all that. Or how tall is the building? If you know how far away it is and the height of any one thing you have at the hand, there's an equation for that. This is the example of the application of algebra in our daily life. Algebra does not even leave behind spots to make use of it. If you look closely, the players of almost all the sports unintentionally apply algebra. The cricketers are able to hit six only because they are able to calculate the force required to hit the ball, and basketball players calculate the trajectory to score a point. In a similar fashion, footballers calculate the force and distance so as to score a goal, and sprinters estimate the speed required to cover the distance to reach the end point. Therefore, each and every sport involves algebra in one way or the other. This is the second example of application of algebra in our daily life. What is logical thinking? Okay, the study of algebra helps in logical thinking and enables a person to break down a problem first and then find its solutions. Although you might not see theoretical algebraic problems on a daily basis, the exposure to algebra equations and problems at some point in life will train your mind to think logically. This ability to think logically will not only help you at home, but also on your workplace and enable you to make mindful decisions at any time. Okay, linear programming. Now we learn linear programming. Linear programming is a way of solving problem involving two variables with certain constraints. Usually, linear programming problems will ask us to find the minimum or maximum of a certain output dependent of the two variables. Linear programming is a way of solving problems involving two variables with certain constraints. Usually, Linear programming problems will ask us to find the minimum or maximum of a certain output dependent on the two variables. And there is a picture below there, and this is the example of the linear programming graph, and its solutions are simple example only. Okay, let's look at the slide. This is the different field of linear programming. The linear programming is implemented in different fields. And the first one is food and agriculture. Farmers apply linear programming techniques to their work. Okay, by determining what crops that should grow, the quantity of it, and how to use it efficiently, farmers can increase their revenue. And in application in engineering, engineers always use linear programming to help solve design and manufacturing problems. For example, in air flight mesh, engineers seek aerodynamic shape optimizations. This allows for the reduction of the drag coefficients of the airflight. Constraints may include lift coefficients, relative maximum thickness, NOx radius, and trailing edge angle. Shape optimization seeks to make a shock-free airflight with a feasible shape. Linear programming therefore provides engineers with an essential tool in a shape optimization. Okay, in transportation optimization, transportation systems rely upon linear programming for cost and time efficiencies. Bus and train routes must factor in scheduling, travel time, and passengers. Airlines use linear programming to help optimize their profits according to different seat price and customer demands. Airlines also use linear programming for pilot scheduling and routes. Optimization via linear programming increase airlines efficiencies and decrease expenses. Okay, this is the problem statement and data. The example. Okay, Benson decides to supplement his pocket money by baking and selling two types of cake, and chocolate and strawberry cake. Each chocolate cake sold gives a profit of 9 ringgit, and the profit of each strawberry cake sold gives us profit of 7 ringgit. Each chocolate cake requires 40 minutes of baking time and use 4s and 4 pounds of flour, while each strawberry cake requires 20 minutes of baking times and use 2s and 5 pounds of flour. If Benson have available only 280 minutes of baking times, 30s and 40 pounds of flour, how many of each type of cake should be packed in order to maximize Benson's profit? Before we do these questions, we need to know model formulations. And what is model formulations? An optimization model of mathematical program consists of parameters. What is parameters? Data that is given from problem statement and fees. Decision variables, variable that represent decision to be made. Objective function, function that decision variable to be minimized or maximized. General constraints, specify all other restrictions, requirements, and iterations that could limit the values of the decision variables. Okay, in this slide, we can see the model formulations is described to 4 points. What is parameter, decision variables, objective function, and general constraints. Okay, let's look at another slide. And the step in LP model formulations. There are 3 steps in formulating the LP model. Step 1 is identifying the decision variable. Step 2 is identify the objective functions. And the step 3, identify the constraint. Okay, solving two-variable LP model. Step 1. Determinations of the feasible reason that defines all solution space of the model. Step 2. Determinations of the optimal solution from among all the corner or extreme points in the feasible region. Okay, this is the calculation step of the first of the questions and the Benson's optimizations model. Okay, just now we look. The step in LP model formulation is the step 1 is identify the decision variable. Okay, what is decision variable? And we explained just now the decisions variable is the variables that represent decision to be made, and it is faces on the problem. Okay, the first one, number of chocolate cake to be produced, and the second, number of strawberry cake to be produced, and the third, time used to baking both cake. From the question uh, we can see the point that question give to us. What is the point of the question is chocolate cake, strawberry cake, and the time to bake both cakes, and the final thing and the final points we need to look at is the how much of each type of cake should be packed in order to maximize Benson's profits, and this is on the third step lah, which is in the second step, which is identify the objective functions. Okay, we look back to the PowerPoint and the calculation step. We already explained, already calculated, already list out that decision variable, which is the number of chocolate cake, number of strawberry cake, and the time used to baking both cake. Okay, to the second, objective variable. The objective variable, we need to know the question what we should do. It is the profit that Benson will gain, and the maximum profit Benson will gain in the fixed point. What is in the fixed ingredients and fixed time, and how to maximize the profit while baking the two cakes. Okay, and we can know the maximized equation is 9c plus 7s. What is 9c? 9c is the chocolate, C is the symbol of the chocolate cake, and S is the symbol of the strawberry cake. And 9c and 7s is represent that the 9 is the profit in the question. It's a profit that each chocolate cake will give a profit of 9 ringgit, and strawberry cake is give a profit of 7 ringgit. Okay, so we use the point that problem give us to list out the equation. What is the profit? What is the maximum profits? Okay, so it is the 9c and 7s. And general constraint. What is the we need to list out the general constraints, which is use other point. Okay, other point is 4c plus 2s smaller equal than 32. And from where we can get these equations? Okay, we look back to the question. 4c plus 2s. What is 4c? 4c is the S, ingredient S, and to make a chocolate cake, the ingredients that required to make a chocolate cake, so it is the 4c. And 2s is the ingredients, is the ingredient of required to bake a strawberry cake, which is 2s. And another equation is 4c plus 5s smaller equal than 40. And what is 4c plus 5s? It is 4 pounds of flour to bake a chocolate cake, and 5 pounds of flour to bake a strawberry cake. And why it is smaller than 40? Because the only available pounds of flour is 40 pounds. And why it is smaller than? Because we bake the cake because we bake the cake only maximum is 40 or smaller than it. We cannot greater than it. So it is smaller than. And for the first questions, why is 4c plus 2s smaller than 32? Because it is the only available for baking cakes is 32. Okay. Look at the third equation. 40c plus 20s smaller than 280. Okay, 40c and 20s is represent that the time for baking both cake. 40c is the 40 minutes is the time for baking a chocolate cake, and 20 is the 20 minutes for baking a strawberry cake. And the only available time is 280 minutes. Okay, so it's our general constraints. And the C is greater or equal to 0, S is equal greater or equal to 0. Okay, this is our calculation step. And we put this calculation step, what is the equations, to our graph. This is our graph. Okay, this is our graph. The graph represents that we put the equations what is we calculate before in this slide, what is the general constraint, and we use these three equations in our graph, and we get the model and we get the graph lah. And it is this region is represent the feasible region. Okay, in this feasible regions, we can use our maximize equations because the questions want us to find the maximum profit. Okay, so we put the maximize equations 9c plus 7s and we use in the graph, and we can get the maximum coordinate in the graph is 5 and 4. Okay, we can look another slide. This is another slide in GSP 5 and 4, and this line represents that the general constraint and maximize the maximize lines. Okay, calculations. The most important we need to know is the question want us to calculate the maximum profit or Benson gains. Okay, so the maximum point is 5, 4, coordinate is 5, 4, and substitute into the maximizations equations. 9c plus 7s equal to 9 times 5 plus 7 times 4 and equal to 73. Okay, conclusions. LP could be helpful to support development of dietary guidelines that fulfill all nutritional requirements. LP also demonstrates to be an applicable tool to consciously convert predefined nutrient constraints into diets with unpredictable food combinations. More studies have used nutritional constraint and cost constraint in the analysis of dietary problems and solutions. But such research begins showing weakness under situations featuring a small number of food items and or nutritional constraints. Introducing acceptability constraint is recommended, but no study has provided the ultimate solutions to calculating acceptability. Only 12 studies apply and introduce ecological constraint. This study showed that the environmental impact of diets can be helped staying within the existing nutritional constraint. LP make it possible to propose diets with lower impact than diet scenario studies. In other words, LP is an important tool for environmental optimization and has a lot of potential. Important is consistency in methodology to derive environmental figures and completeness of constraint. Future possibilities lie in finding LP solutions for diets by combining nutritional cost, ecological, and accessibility constraints. LP is clearly a very helpful instrument for finding solutions to a variety of complex diet problems. Okay, and from these slides, we can know the linear programming and the LP is the model we can help us in many fields. And that's all from me. Thank you.